For our Crumble project on creating a river pollution monitoring device, this is how we would connect it up. So the components we're going to use is a battery pack, Crumble, 2 sparkles. One sparkle's just going to be a light source for the side of the glass. The other sparkle is actually going to be the indicator that tells us what the quality of the water is. And then we've got the light dependent resistor, which is going on the side of the glass, or the kind of monitoring chamber, as I keep calling it. And this is the buzzer that's also going to be forming part of the alarm. Now, if you don't have lots of sparkles, you can actually replace that sparkle with a standard school bulb, a sort of DT bulb with 2 croc clips. You just have to connect it to the Crumble down on one of these motor channels. And I find if you run that at about 75% of the power of that channel, you get a really bright light. You just got to tape a bulb on the side of the cup or the chamber. So let's get started. So we take a positive from the battery down to the Crumble, and we take a positive from the Crumble to the first sparkle, and we daisy chain the 2 sparkles together. And we need to take a positive which can come off the battery or the Crumble to the LDR, and also one to the buzzer. And you find that there you've got 3 croc clips, so you might well want to put 1 or 2 of those onto the battery over here where you've got a bit more space. So we take the negative into the negative of the Crumble, and we take a negative into the sparkle. We take the signaling channel, it has to be D. It has to go on this end of the sparkle where the arrows come in, so the left hand side of the arrows. We pass that over to the second sparkle. So that's sparkle 0 if you remember when we're programming it, and that's sparkle 1. Okay. Right, the LDR still needs another connection. So we'll take the other connection of this, we'll put this on A on the Crumble. So that goes on the input channel A. That's how we take a reading off it on A. And then the other one we've got to connect is this end of the buzzer, which we can put on B. And that's our connectivity done. If you remember, this device is an analog device, so we take a kind of analog input reading on A, and this is a digital device, and we activate the buzzer by taking B low. So that's the physical connections. So here's the equipment that we use with the Crumble controller to create a kind of river water quality monitor. We've got our battery pack, and we've got our Crumble over here, and just like I've already shown you, to try and simplify it, I've put the connections for the buzzer in white. The buzzer takes a positive and a negative connection. I've got the buzzer connected on channel B of the Crumble. The LDR is inside this cup. If I just tilt it, you can see all I've done is sort of taped it to the side of the cup, and so it's just in there. Oops. And I taped it just to keep the light from seeping in from behind it, so it's just taking light from the cup. And on the other side of the cup we've got this sparkle, which is I've created just to create a kind of permanent light source, if you like. I don't think you technically need that one, you could probably do with that. So then that leaves this sparkle here, which is our kind of warning or indicator of water quality, along with this buzzer over here. So they actually sort of tell us the quality of the water. Okay, so that's kind of like the testing chamber. We start off with a beaker of clear water, and I'll show you the code behind this in a moment. But for this, to pollute our water, and this kind of, obviously because this is a model, this is a prototype, or something like that, of what would become a real system, we just start adding pollution to the water. Our
water gets a little bit cloudier and cloudier. Takes a while for this instant coffee. This is instant coffee, by the way. Takes it a while to dissolve and into the water. But eventually the water reaches a level of pollution where the monitor comes back on. And it's obviously kind of like as the water gets more and more opaque, there's less light going to the LDR, and we've got the warning system on. And obviously you could get the children to extend. I'll just turn off the buzzer because it's a little bit annoying while you talk. You could extend that project for the children by then saying to them, okay, let's have a gradual warning system where we get perhaps some flashing and a little bit of bleeping of the buzzer as the water gets slightly cloudy, and then as it gets really dark, then we have the full-on continuous light and the continuous buzzer. You could also extend the complexity of it for the children by saying build in a button into the circuit, so that the testing only takes place when the user presses a button. So instead of being almost like a continuous monitoring system, you can imagine this as like a chamber or a float by the side of a river. Then they're taking perhaps a water sample and putting it in a machine. You press a button and it gives you a reading. So that would be one way of making it more complicated if you wanted to extend the children. There will be a link on this video that shows you where you can download all the lesson plans that build the children up to these skills one step at a time, and show them how to program the sparkles, the buzzers and the buttons and the LDR. And I'll edit that link, and you should see it in fact on the screen now. That's a link to where you can go on the CAS Computing at School website and download the full set of lesson plans and all the little code snippets and things that I've put together as well.
Just a quick look at the code behind the water quality monitor. This is the Crumble code. First thing it does is switches the first of the sparkles in the daisy chain. That's the one that kind of illuminates the test chamber. Turns that on, and then you go into this repeat loop here forever, setting a variable that I've created under the variables tab called brightness to be whatever reading is currently coming in on the LDR, the light dependent resistor, which is connected to channel A. So brightness is then set as a number. And if you want to try this, when you look at this panel, you'll see the current value for brightness there as you run the code. So then it says if brightness is below a certain value that I just picked that was slightly less than what brightness is normally if the water's clear. And then you set B to low, which activates the buzzer, because the buzzer is connected to B. And you set sparkle 1, which is the indicator sparkle, to this red warning colour. Or if the brightness is not less than that, which means the water is clear, you do the second part of this selection, you do the else, and you actually make sure the buzzer is not activated, and you make sure that the indicator sparkle is set to just white to show that there's no problem with the water. And that's the code, and that's the simple version. And if you want the more complex versions with flashing sparkles and things, do look at the lesson plans. I think it's on lesson 3 that there's code samples there that show you how to do the slightly more complex version of warning.